So I want to look at reminding you about simplifying a radical. So let's break down 108. This is an even number, so 2 goes into it. So let's divide by 2. 2 times 54 will give us 108. Now 54 is also divisible by 2. And 2 goes into 5 2 times with 1 left over. And 2 goes into 14 7 times. Now right off the bat I see I have 2 of 2's, 2 of a kind. So no, a 2 can come out. Now let's look at 27. 27 is 3 times 9. Now 9 is a perfect squared number. So I know I have 2 3's, so a 3 can come out. We have this one number left over here. So that number has to remain in the radical. It does not have a pair. So we're going to multiply what's on the outside. So we get 6 square root of 3 would be square root of 108 simplified. Now this is what we did yesterday. So today we're going to put variables with it. Yay! I'm going to put some letters in here. All right? So let's look at a couple of examples here. So we're going to treat our number exactly the way we've been treating it. We're going to break it down, maybe see if we can find some perfect squared numbers in there. Well, 9 will go into 180. 9 goes into 18 2 times, and then you have that 0. So 9 times 20 is 180. 9 is a perfect squared number. So I know a 3 will come out. 20 is 4 times 5. 4 is a perfect squared number, so I know a 2 can come out. This 5 is all by itself. It does not have a pair, so it has to stay in. Now I'm going to not draw that radical yet. We're going to look at this variable. X to the third can be written as x squared times x. X squared can be written as x times x. I have 2 x's, so an x can come out. All right, now look at what we're doing. We're breaking down our numbers and our variables. For the numbers, when I have 2 of a kind, those numbers come out. That term comes out. In the variables, when I have 2 of a kind, that variable comes out. Okay? Now, I want you to see what is left over. So I'm going to use a different color here. This is left over, so that stays in the radical, and this is left over. These two numbers were not, or terms were not paired up, okay? So inside the radical we have this 5 and we have this x. Outside the radical we have 3 times 2, which is 6x. So our answer is 6x square root of 5x is how you would simplify the square root of 180x cubed. Now, I want to make variables as simple as possible. So we're going to break down the numbers just like we were doing. Nothing on those has changed. If you remember a perfect squared term, then by all means use it. If you look at this next one, 15 times 15 is 225. So this is a perfect squared term, okay? So that's a perfect square. We know 15 comes out. Now the fastest and easiest way to determine how many variables come out is to do this. Divide the exponent by the root leftovers stay in. I'm going to explain that. All right. So this has a square root. That means there's an invisible 2 there. So that's why we're getting 2 of a kind in order to come out of the radical. So let's divide. 2 goes into 5 twice. That's how many x's you can get out. And if I divide 2 into 5, I have 1 left over. So that means I'm going to have in my radical 1x left over. Okay? Then 2 goes into 3 one time. So I can get 1y out. And if I divide 2 into 3, I have 1 left over. Okay? So that 1 that's left over stays in the radical. All right? So the square root of 225 simplifies to 15. The square root of x to the 5th simplifies to x squared square root of x. And the square root of y cubed simplifies to y square root of y. Okay? All right, now I know when we get variables in here, it's a little bit more complicated. Okay? If you would like to break down the variables like we did in this first example, then you most certainly can do that. Okay? I think that some of you will be able to do the dividing into the exponent and get the leftovers. Okay? So I'm going to do another example where I'm breaking down the variables. Okay? So let's look at the number first. So if I look at 175, the first thing that comes to my mind is 25 will go into this number. Okay, so let's just think if we had $1.75, how many quarters will that be? That will be 7 quarters. 4 in the 100 and 3 in the 75. Okay, 25 is a perfect squared number. So 5 is going to come out. 7 is not. Doesn't have a pair. All right, let's look at our variables. M to the 9 can be written as m times m to the 8. And if I have an even exponent, that's m to the 4, m to the 4. Because remember, when we multiply like bases, we add exponents, right? So m to the 4 times m to the 4 is m to the 8. Now, this is a pair. So m to the 4 can come out. M cannot. It did not have a pair. Okay? N to the 4 we can split up into n squared, n squared. We have 2 of a kind, so n squared can come out. Now, we did have some leftovers, so I do want to point those out to you. 7 was left over, and m was left over. Okay, so those leftovers stay in the radical. They do not come out. So if you were going to simplify 175 m to the 9th square root of 175 m to the 9th n to the 4th, you would get 5 m to the 4th n squared square root of 7m. Now I'd like for you to pause the video and try one of these just to see if you're understanding what to do, and then you can look at the explanation. Okay, so I would take 160 and divide it into 16 times 10. 16 is a perfect squared number, so we do have 2 of a kind. Now 10 we saw earlier in another video that that's only 2 times 5, so we wouldn't have anything to pair it up. That's left over. Okay? A squared can be written as a times a. That's 2 of a kind. It can come out. B to the 4 can be written as b squared, b squared. That's 2 of a kind. It can come out. So I had one term that didn't pair up, and that was 10. So we're going to leave the 10 on the inside. All my variables got split up, and they got removed from the radical. Okay? So if you have a square root, that means there's this invisible 2 sitting in here, and you need 2 of a kind in order to get out that term. Okay? So let's try a couple more. Just want to have plenty of practice. These are our last 2 here. Okay? So let's look at this one. 2 will go into 52. And if we divide 2 into 52, we get 26. Okay? 26 can be divided by 2. So 2 into 26 is 13. Now I do have 2 2's. So I have a pair, the 2 comes out. Okay, now I usually circle all my pairs, like this is 2 of a kind, I'm circling that. All right, let's look at our x squared. That can be written as x times x. We have 2 of a kind, therefore it comes out. Y to the 4th can be written as y squared, y squared. That's 2 of a kind, it can come out. Z to the cube can be written as z times z squared. I'm going to put a line through my z. And z squared can be written as z times z. That's 2 of a kind. So a z can come out. All right? Now I do want you to see what's left over. 13 did not get paired up, and this z did not get paired up. Therefore, the 13 and that lone z have to remain in the radical. Okay? Now for your variables, you want to get them to be an even exponent. So this is already an even exponent. We split it up to 1 and 1. This was already an even exponent. It was a 4, so we split it to 2 and 2. This was odd exponent, so we pulled one of them off to get it even, and then we split the even into 1 and 1. Okay? So let's look at this last one. 144 is a perfect squared number. That is 12 times 12. So it comes out. If I want to make a cubed something times an even power, I will take off the odd number and multiply it by a squared. Okay, so that means a squared can be written as a times a, and an a will come out. B squared can be written as b times b. We have a pair, so b can come out. C cubed, we'll write it as c times c squared, and then we can split c squared up into c times c, so a c will come out. Now, we had everything paired up except for this c and this a. Everything else got paired up. There were 2 of a kind. So these 2 things, the a and the c, are left inside the radical. Okay? Now I said I'd do one more, but I want to do one more for you. I thought those were the only ones. I do want to do one with several variables in it so we can get the hang of this, okay? So I'm going to do one with just variables. Let's do w, x, y, z. Alright, so they all have different exponents. So let's see. Some of them are odd, some of them are even. So what we want to do with w to the 5th, we want to split it up into w and w to the 4. Okay, take off the odd one and make it have an even. Then w to the 4 will split to w squared, w squared. That is where your pair comes in. Okay. X is already even powered, so that's x3 times x3. Remember, when we're multiplying like bases, we add exponents. So x to the 3 gives me 2 of a kind, and it can come out. Let's look at y. It's odd, so I'm going to take the odd number and then y to the 6. Remember, because y to the 1 and y to the 6 is y to the 7. So now we're going to split up y to the 6 into y cubed and y cubed. There's 2 of a kind, so it will come out. Z to the 3rd. We'll take the odd one out. That leaves z squared, and that can be written as z times z. So the z can come out. Whatever is left over remains in. So w, y, and z will remain in the radical. Okay? Good luck.